Good morning, guys. One more time. So let us continue what we started yesterday. We started with very basic things. We said like what exactly a language means, what are the different types of languages, something like compiled language, something like interpreted language, and the other derivatives like style sheet language, markup language, and all of these things we have discussed yesterday. So probably now you know what exactly the language and the language fundamentals are. And based on that, we started talking about something like a Python's very basic. I mean, we have written a hello world application yesterday, and we already have seen it is one of the simplest language to learn. So now today we want to continue further and we want to start writing some serious code. But before we talk about the serious code, let us talk about what exactly happens when you start writing the code and when you run your application, when you run your Python application. So that is very important to understand, so that there are many different concepts that are dependent on the topic or dependent on the logic we are going to discuss today. So we did we discussed this yesterday, like what Python is used for, and this is again just scratching the surface. There are n number of other domains where Python can be used, and Python is getting used. This is just a bunch of common ones or very frequently used domains. Okay, so if you want to use it, I think you already have gone through the environment setup, and I'm assuming that everyone is running Python. Everyone is running Python, everyone is running PyCharm. So probably we can start writing code together. Now, once the environment is set up, we want to start talking about the actual Python. Now, when we say Python and when we start writing the code, probably you can recall, before I go to this, let me write a very, very simple hello world kind of application. Let us see what and how we can deal with it and how we can, just move it accordingly. Okay. So this is your PyCharm. Probably you want to start writing the code directly inside the PyCharm. That will be very easy. There are so many IntelliSense shortcuts I'm going to share right where we want to start writing the code. So continue with this. Open your PyCharm. Go to open. Do not create a project at least today or at least couple of days. So start creating a directory. So click on open. Then go to the directory where you want to store the data. I'm going to go to my 2020 February workshops Python 04. I already have created a directory D2, and I'm going to write my code here. So when you open this with PyCharm, probably you can see on the left hand side, this is called as the project explorer. So right here in this particular area, you will see all the files, all the different type of libraries or all the different type of packages you are using in your application. So once you do that, probably you can right click on this and say new and say Python file. Now here you can write anything. I mean, for me, I'm going to use page 1, page 2, page 3, and so on and so forth. So probably I'm going to say this is my page 1. Right here, there is a code area where you can start writing the code. It's pretty simple to understand, and being a developer, probably you can easily guess what exactly it is and how exactly you can use it. So this is the code area. Here we have to start writing the code. If you can recall something, I said that there is no entry point function in Python. You start writing the code, and automatically when you run your code, your first line of code will start getting executed. So probably here, I want to say again, print, and there I will say hello world, as simple as that. How do you run the application? Again, very simple. Right click on that and say this is run page 1. Now, probably when you say run page 1, right next to it, you will see the shortcut as well. So for me, it is Control-Shift-R. For you, depending on your operating system, you can check what shortcut you see here, and next time onwards, you can start using the shortcut as well. So probably I can say run, and when I run this application, I see that hello world right here on the console. What do you see on the bottom? This is the console area. So here you are going to see your output. So probably when you say something like a application is getting run, the application will produce the output, and the output will be shown right here in the console. This is the code area. This is the console. And again, you can just collapse that console if you don't want to use it, but keep it open for now so that we can compare the code and the output and see whether the output is right. Okay, now when you talk about this code here, this code has nothing but a single statement, print. But before we talk about some complex applications, let us understand what happens behind the scene when you create or when you start writing any code in Python. Any in the sense you can write a single code or single line of code, or you can write multi-file application as well. The logic is going to remain same. So let us understand what happens when you run your code. To understand that, we have to come back here and see the actual transition or the actual convention that is used behind running the application. So probably we said that this is where we are going to write the code. Say this is my python.py file. Now inside this py file, you might write your code, you might write your single or multiple files. So probably I may say very simple, like what I said there, print hello world. I'm going to simply say hello here, doesn't matter. There is no need of semicolon. You just write the code and then you can start compiling it or you start running it. So this is my .py file. This could be hello.py, this could be anything, page1.py, whatever it is. I'm going to say hello.py for now. So this is the file that I want to run. Now basically, if you can recall, we said that yesterday as well, there are two types of languages. One is called as a compiled and other one is called as interpreted. In compiled languages, your entire source code gets converted into an executable. And when I say executable, that is a native executable. When I say native, that simply means it is a platform dependent, because it is going to have the assembly code, and that assembly code is tied together to the operating system for which you are compiling it. So when you talk about this code here, the Python code here, now Python is a mix of both the languages. In case of compiled languages, the entire code gets converted into the executable and you get one file to execute. But in interpreted languages like Python, like JavaScript, like PHP and all of them, you do not get any executable. You simply start writing the original code. So basically, this is my code, hello.python, and this code I want to run. Now, how do I run this code? Right now, we are using the PyCharm here, and then right clicking on this and we are saying run the page application. Now to be precise and to be honest, this is a kind of shortcut we are using. Actually we should not, but because we don't have that much of time to go through every single thing, we started using the PyCharm, and we will use PyCharm so that we can get the nice IntelliSense and shortcuts and other things. But to be precise, again, let me go to that directory. Let me go to that directory where I've created it on my command line. You don't have to do that. I'm just showing you something. Say this and get whether you can understand this or not. So this is Python 04. This is day 2, and here I am. This is my file, page1.py. So what happens behind the scene when you say right click and run? Behind the scene, your PyCharm uses a compiler. That compiler compiles your code and then it executes your code immediately. So what happens here? Let me show you here. So when you say something like Python, the Python 3 is the utility, or Python 3 is the compiler we are using here. So we say Python and say page1.py. Now see, when I executed that code from here, I got a hello world on console. When I executed here on my console or on my terminal or my command prompt, I still am getting the same output. No matter whether you are doing it using command prompt or using PyCharm, ultimately output will remain same. But in this case, I mean, when you are on the console, you have to use the utility, you have to use a compiler called as Python 3, and Python 3 will execute your code written in page1.py. You have to do it every time if you're using, but right now, you know, I don't want to waste my time to write the code here or to see the issues and then waste again more time to investigate that issue. That's the reason why we decided to go with PyCharm. So behind the scene, when you say right click and run, behind the scene, PyCharm is also going to invoke the same command. PyCharm is also going to use that Python 3 and will pass that page, the page on which you're right clicking and executing it. And then it is also doing the exact same thing. It just, we don't have to do it. PyCharm is doing on behalf of us. So either one, when we want to execute the code, probably we have to use this Python 3. Now, what is that Python 3? That's what I wanted to show you here. So see what we have done and see how it is a little bit different than other languages you might have seen earlier. So this is Python hello.py, and this is the Python code we have written inside it. Now to execute this, we are using a utility or we are using a compiler. So we say something like Python 3, and then we say something like a hello.py. So this is the command that we are using. Now what is this command? This command here is going to compile your code. Let me use my word one more time, and I'm being very cautious here. I'm still saying compile code. So basically, if you can recall, yesterday I said a couple of times that Python is an interpreted language and I used asterisk mark there. I used asterisk marks because it's not only an interpreted language, it is also a compiled language as well. So what happens here is what I'm trying to show you here. So you have the hello.py, this is the Python code. You are passing that code to a utility or to a compiler. Basically the Python 3 here is a compiler. Let me mention that. This is the compiler, and this compiler literally reads your code, whatever is written inside that .py file, and converts it into another format. So basically I'm going to come back here and I'll say that this will get converted into another format. So here you are going to get something. So probably I'll just write here as something called as the bytecode. So when you are using hello.py, behind the scene, the Python 3, that is the compiler we are using, is going to compile your code and will convert it into bunch of bytecodes. It uses an extension, something called as a PyC. So this is the PyC. The PyC is going to get converted, or PyC is going to get compiled all the time. So hello.py gets converted into .pyc. PyC stands for Python compiled code. What will you find in PyC file? You will find only the bytecodes. Now, if you really want to see this, what happens with compared with the other languages, you might feel a little bit similar thing in C as well. So probably let's assume that you have written hello.c. I'm not asking you to use that C and just try it out right now, but just remember what I'm trying to show you here. So probably you might say something like include blah, 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 integer mean, and so on and so forth. So you are going to write your code here in case of C, something like this. And then if you want to run this code, you first have to compile this code. So how do you compile this code? You compile this code by using C compiler. So probably if you are on Linux, then you can use GCC. If you are on Visual Studio, or if you are on Windows, you can use Visual Studio Code's cl.exe, and there are a bunch of other options. So you can say GCC hello.c. So this is the file hello.c, which contains your source code. You are passing it again to the compiler, and compiler here is going to compile your code. Same story. So compile the code. But there is a small difference here. So when you compile the C code, basically it gets converted into an executable. So this is my executable, or this is my assembly code. Maybe you can say this is something called as an object code, OBJ, which contains the assembly code. This is the big difference. Assembly code or assembly output. So basically whenever you are using the hello.c and you are compiling it, you are going to get an object code. But when you are compiling the Python code, you are going to get something called as PyC and something called as a bytecode inside it. Now, when you are using the object file in C case, you use the next phase to create an executable. You use something called as a linker. So basically I'm going to say that this is linker. Because I'm using a GCC here, the linker is called as LD. So LD is the default linker which is used on the Linux platform. So this is the linker. Depending again on which platform you are running or which platform you are compiling and linking your application, you are going to get a little bit different extension and a little bit different file format as well. So this is the linker which is going to link the code. So linker is going to use the OBJ file which is created in the previous case, and it is going to add different libraries. So this is the library or different libraries, and those libraries along with the OBJ file will be added here. Again, what you are going to have here is assembly code. That is not going to change. So this assembly code plus libraries will create your executable file. Now because I'm on Linux it is by default going to spit out a.out. Now a.out is going to have an executable and a linkable file format. This is called as a ELF. So basically depending again on your operating system, you might get a different extension. If you're on Windows, you are going to get .exe. If you're on Mac, you're also going to get the a.out. And if you're on Linux, again, it is going to give you a.out. This is what you are going to see, or you must have observed in case of C. So in case of C, whenever you are running the code, this is what is going to happen. Basically, you are not going to run your code. You are going to run your executable. So this is the one which is a kind of executable. Because we are using a C is a compiled language. It creates your executable from your source code, maybe all code at once. It's not like it is going to do it line by line. It is going to do every single thing at once. And next time onwards, you are going to use this code to, or this executable to execute. Now see what happens here. When you are in C, the object file and the executable, they are having the assembly code. Now, when you say you are having the assembly code, naturally, this assembly code can directly be executed by using CPU. And that's the reason you might pass this A dot out to the CPU, and CPU happily execute your code. So CPU says, yeah, I can understand the assembly code, just pass it on, I'll execute it for you. So basically you have that A dot out, you pass it to the CPU, and CPU happily executes your code. So this is how the C code gets compiled to an executable, and this is how you can use that executable in order to see the output by using the CPU behind the scene. So CPU is the one which is going to do the job. Now let us see what is the little bit difference you will find here in case of Python. So first phase is exactly similar. So you are using a compiler, you are passing that hello.py, and you are getting a kind of PYC file. Here you are getting OBJ file, here you are getting PYC file. PYC stands for Python compiled code. Now this is the big difference. Here you are having the assembly code, and here you are having the bytecode. Now what is a bytecode? The bytecode is the one which is internal representation of your compiled Python code. This is assembly code which is made for a certain CPU, and that's the reason we can directly pass it to the CPU. Now this bytecode is not for the CPU. In a sense, if you directly pass this to the CPU here, maybe I'm just going to say that this is the CPU and I want to execute that code. So if I directly pass this code here, this is not going to work. Why? Reason is very simple, because CPU says, hey, I can understand assembly, and what you are having is nothing but the source code, nothing but the bytecode. So basically I cannot understand bytecode, and that's the reason CPU says I can't execute your code. So if CPU cannot execute your code, who will execute then? Ultimately CPU is the one, or CPU has to be the one who has to execute the code. But I cannot directly pass this code or to the CPU, and that is the reason we have to take one more step in between. So to execute this code, we are not going to pass it directly to the CPU. We will say, hey, I think we need someone to convert this bytecode into assembly code. And that someone is nothing but another entity. Let me add it here. And we generally call that entity as the PVM. So this is called as Python virtual machine. So this is the PVM, and this PVM will be used to execute your code. Now, how does it get executed here? Again, behind the scene, this is the Python. So Python 3. And do I have some space here? No, I don't have. Just give me a second, guys. Let me just move it a little bit on the right hand side, so I'll get some more room. And then I can say, this is what is going to happen again. So basically on behind the scene, it is going to use the same utility, Python 3, and then it is going to pass hello.pyc. Now what is that PYC? The PYC is the one which contains the bytecode. Now here Python 3 was acting as a compiler. Now when I say compiler, it was compiling your code and it was converting the source code into bytecode. But here utility is same, there is no change here, but Python 3 is acting as something called as an interpreter. Interpreter means it is going to get every single instruction, every single bytecode from that PYC, and then it is going to convert it to the assembly code, and then assembly code gets passed to the CPU. So this is the way the conversion happens, and this is the way your actual code gets executed here. So probably I'll say that this is the way you are going to pass it to the CPU. So basically in this case, Python 3 interprets the code. Interprets the code. Interprets which code? Bytecode. So basically when you're talking about the Python's execution, Python execution involves Python 3. That is the sole utility, but that works in two different phases. In the first phase, it acts as a compiler. So this compiler literally converts your code, source code, into bytecode. So this is the first phase. And in the second phase, the bytecode, which is not understandable by the CPU, gets converted or gets loaded into this PVM. So maybe I can say this is the hello.pyc somewhere here inside that PVM. And the PVM literally converts every single byte instruction, every single byte code instruction to the assembly instruction. So basically, I'll just say here, the byte code gets converted into assembly code. Or maybe I can say somewhere here, assembly code. And this conversion happens every single time you run your code. So again, you see that there is one more extra step involved here, and this is the way it executes your code. So whenever you are saying the Python code is getting executed, there are two phases into it. First phase is the compilation, and second phase is the interpretation. Naturally, people generally do not know that it happens behind the scene, because you will never see that .py file. So basically, in case of C also, the object file gets automatically deleted after the executable gets created. Similarly, here also, in case of Python, PYC file gets deleted automatically when it gets the bytecode out of it, and then it directly executes the code and shows you the output. PYC file gets automatically deleted. You don't see that file there. Of course, there is another way, but not today. We'll see that later, because later we have one more session where we have to talk about the PVM architecture. There I'll explain different parameters we can pass to the Python in order to see that PyC file, in order to see or peep into the PyC file and literally peep out all the bytecodes there. So right now, just understand, this is an overview of what is going to happen every time you run your code. The PVM here, let me just mention one more time. So PVM right here, it stands for Python Virtual Machine. The good thing about the Python virtual machine is, like, when you are having the Python virtual machine in between, you might see that it is kind of an overhead. It is kind of an extra step. Look at the C. C case is very simple. C case, we are having an executable and we are directly passing it to the CPU, and we are getting it executed there. It is so fast. Indeed, it is fast. It is faster than Python, because you are directly having entire code in a.out. You don't have to do that one by one. You directly pass that a.out to the CPU and get the output. Indeed, it is faster, but you are losing one most important point here when you talk about that a.out. Let me mention this completely. I don't want to, but it's okay. So when you talk about this a.out, this is nothing but your executable. Now let me use a different color. I'll say that this is an executable. And when you say this is an executable, this executable right now is kind of for Linux, it is kind of ELF. Let me mention for all three platforms. Fortunately, I'm working on all of the, so I can tell you that as well. So when you talk about the executable here, the executable for Mac, it is kind of March. Oh, this is a file format, and this is going to be a.out, generally a.out. When you are on Linux, this is going to be something called as ELF. ELF stands for executable and linkable file format. This is also, extension is generally O or a.out. And finally, for Windows, this is going to be PECOF. Let me just make it a little bit aligned here and say this is going to be something called as PECOF /COF. Portable executable common object file format, and generally this is something like something like a hello.exe. Okay, so when you talk about the Windows, you are going to get an executable which is having a file format of PECOF. When you are on Linux, you are going to get a.out, which is having a file format of ELF, and when you are on Mac, you are going to get again a.out, which is having a file format of something like a macho. PE stands for Portable Executable Common Object File Format. Not necessary that everyone needs to know it, but I'm just telling you, because when you are creating that executable, this executable is not cross compatible. In a sense, if you copy this a.out from Mac to Linux, this is not going to work here. If you copy that hello.exe on Mac or on Linux, this is also not going to work here, and neither this will also work. So basically, they are not cross compatible. In the sense, when you are getting a Windows executable, it will work only on Windows. When you are having a Linux executable, it will work only on Linux. And that is the main drawback of using a C language here. So C is faster, no doubt in that. You are getting the assembly code directly. You are directly passing that assembly code to the CPU, and you are going to get the fastest performance or the best performance out there. but you are losing something like a platform independency here. Your application or your code or your executable becomes platform dependent. If the code is or your executable is platform dependent, that means if I want my application to be compatible on all three platforms, on all three operating systems, I have to compile my application 3 times. I have to execute this, I have to link this 3 times. I have to link it on Linux, I have to link it on Mac, and I have to link it on Windows in order to create these different executables. And that is the main drawback of using C. But when you look at the Python, Python is not in that case. I mean, Python does not fit in that category. I mean, though this is a kind of bytecode here, which is similar to what we have seen in C, but this is the magical moment, or this is the one which is kind of very different from C. So when you talk about this part here, this is the PVM, and PVM is kind of making your code or making your Python platform independent. How come it is doing this job? It is doing this job because PVM itself is the platform dependent. So maybe I can say that this is the platform dependent. Now, when I say platform dependent, get this thing. Platform dependent simply means the PVM for Windows is different. PVM for Linux is different, and PVM for Mac is different. To be precise, if you have done that installation yesterday, you might have noticed that when you were downloading Python, you were getting 3 options. Either download that Python for Mac, or download it for Linux, or download it for Windows. Which means when you are downloading the operating system specific format, operating system specific version of your Python, the operating system specific version of Python is also downloading and installing the PVM, which is actually made for that particular operating system. Which means now the Python virtual machine is available for all the platforms, and because of that, no matter what you write here, your code will just directly get executed inside the PVM, and it becomes platform independent. So PVM is platform dependent, but Python is platform independent. So Python language itself is a platform independent, and when I say platform independent, this is the secret behind it. What makes your Python platform independent? This is the PVM. The PVM stands for Python virtual machine, is doing its job by providing you a way to execute your code on all 3 platforms without changing a single line of code. That is what it goes behind the scene. So when you are here on let's say PyCharm or on console, and when you say run this code, or when you say run this code on console, Python 3 page 1.5, this all happens behind the scene. First, it gets compiled to bytecode.pyc file. Then bytecode gets converted to the assembly code every single time, line by line, instruction by instruction. The CPU executes that code, passes it to the PVM, and PVM shows that result to you. So we don't really realize it what happens behind the scene, but believe me, this is what is going to happen. This is what happens every single time. No matter whether your code is of single line or the code is of thousands of lines, the story will remain same. That is the reason I wanted to cover that before we start writing the huge lines of code. So you will see what exactly happens behind the scene. Guys, are you getting it? Any questions so far? I see there are a couple of questions, but I hope you already have got the answers to them. That's the reason I didn't look at the questions, because I know what type of questions you are asking. So accordingly, I changed my context here. So probably all of the questions are probably answered. Someone was saying, is it similar to JVM? Exactly similar to JVM. If you just say, just change this Python's .py, and if you change it to Java, and if you see, if you just convert that PYC to temporary bytecode, and if you simply replace this PVM to JVM, the same story can be applied to the Java world as well. So this is exactly similar to Java. And normally, you know what, normally people doesn't care about it, but I do care about that, because this is the way you will understand what happens behind the scene, and this is the way you will see why Python is a platform independent. So you write it only once, and the Python can be executed anywhere. It can be a very simple application, it can be very complex application, steps will remain same, and it will run it will run on any platform. Can be executed on Linux, can be executed on Mac, can be executed on Unix, can be executed on Windows as well. So this is how it goes. Okay, What is an extension after PVM step? There is no extension. There is no extension here because after that there is no executable. The PYC file gets loaded into the PVM, and in the PVM itself, it will read the instruction one by one, and it will get converted to the assembly code. Just for an example, say this is the bytecode here. So probably I can say inside my bytecodes, there is a bytecode B1, there is a bytecode B2, and there is a bytecode B3, for example. So when this file gets loaded into PVM, PVM will convert that B1 to A1. Now just understand, B1 for bytecode 1 and A1 for assembly code 1. B2 to A2 and B3 to A3, and so on and so forth. So there is no further file gets created after the P1, after PVM. PVM is the one which converts that B1 to A1 all the time. I mean, it happens every single time you run your code. The only small difference between the C or between the compiled and interpreted language is this. Here, it happens only one time and you get the final assembly code in the sense, the final executable which contains the assembly code. Here, this story happens every single time you run the code. And that's the reason Python is a little bit slower than C. But the main advantage of using Python is its platform independence. So your Python code is platform independent due to the fact that the one which we are using here, that's PVM, is a platform dependent. So PVM is a platform dependent, and which makes your code platform independent. I hope you are getting it. Okay. So hopefully, who's that? Okay, Adesh, I think this is the answer to your question. Okay. Omkar, can you please repeat the PVM platform dependent? Fine, no worries. When you say PVM, PVM is a platform dependent. In a sense, when you are installing Python for your operating system, the Python behind the scene, the Python installer behind the scene installs the compiler, interpreter, as well as the PVM for you. So normally you will not notice that, but everything will go on your machine, and that is a platform dependent. And that's the reason when you were installing it yesterday, you might have seen that Python comes in 3 different flavors. When I say 3 different flavors, this is how it goes. Just give me a sec. Let me go back here, open the same again. I'll say that this is going to be the Python download directly, or you can say python.org/download. That's okay. So if you go here, you notice that Python can be downloaded for Linux, Mac, and Windows separately. You cannot just download it for Windows and install on Mac, or you cannot just download for Linux and install it on Windows. It's not possible because this package contains your compiler, interpreter, as well as the PVM. And PVM is the main job. PVM's the main job is to make this platform independent. I hope you now are getting it. So Omkar, I think you must have got it here. This is the way it works. Okay, Pranit. That means the bytecode from PVM is independent of platform. It is no, it's not independent from platform. It is independent from operating system, but dependent on the CPU. Now it's a little bit different here, but I hope this is a kind of similar to C here. I mean, when you are using CPU of let's say x86 or CPU of MIPS or CPU of ARM, the instructions will vary. The assembly code will vary, but again, Python will not change. So Python will get converted into the CPU beneath automatically, but the Python code will not change. Okay. So when I say platform, just get it as a operating system and not the CPU. CPU, when it changes, the assembly code changes. So the PVM will also change. So PVM for ARM will be different than PVM for x86, than PVM for something like MIPS, than PVM for something else. So PVM will change, but operating system is independent. I mean, it's operating system independent, but it is CPU dependent. It's not only PVM. This is also true for your C code as well. I mean, C code is operating system dependent, at the same time CPU dependent as well. Anyways, that's a long shot. Right now, just remember that this is the way you are going to make your code platform independent. And when I say platform, please remember this is an operating system I'm talking about. Okay. Okay, Gaurav, in C also we write the code in the same way for all platforms. Only difference is the compiler and then how it is different from Python. Didn't you notice that when you are using the compiler here, you are getting directly the executable. And when I say executable, it happens it happens like it gets all the instructions written in your C code and gets converted into assembly code at once. There is no there is no conversion happens when you are executing the code. Before you execute the code, all the instructions will get converted to assembly all at once. Here, this story gets repeated every single time you run your code. So when I talk about something like getting it executed by using that instruction, where is it? Here it is. So getting it executed here, I executed that 3 times. This story has been done, or this story has been converted, or the story has been implemented almost 3 times because I've executed that 3 times. Here, the conversion will happen only once, and you are going to get an executable. You can execute it as many times as you want. After getting the executable, there is no conversion needed because the assembly or the executable already contains the converted code. So after this, there is no conversion. After this, directly execution will happen. But here, even after you are having the PYC, every single time PVM is going to convert that PYC's bytecode into something like a assembly code, and that's a reason it's a little bit different than C. Okay, so Gaurav, I think you got your answer here. Okay, who's that? Preeti, there are multiple options for selecting the Python interpreter, like V environment. Where should we configure it on Mac? Do not create a project right now. Just open a directory. That's what I said earlier. We have to look at the virtual environment. VNV stands for virtual environment. We'll talk about that later. Right now, just open a directory in your PyCharm and start with writing the code there. Do not create any project right now. Okay, Sagar, your question in Python, what does the interpreter do in with respect to the PVM? Interpreter here interpreter is going to load that bytecode into PVM. Interpreter is going to actually do that job here. So here Python 3 is not actually an interpreter. Python 3 loads that code in PVM, and PVM acts as an interpreter. I mean, though I'm saying the Python 3 is acting as an interpreter, this is not the actual Python 3 who is doing the job. The actual code will get compiled or will get converted to assembly by using PVM. So if you want to be very precise, though it says that Python 3 is a kind of interpreter, to be very precise, PVM is doing the job of interpreter. Okay, so Sagar, in Python, when you're talking about a Python 3 acted as a compiler last time, and Python now is acting as an interpreter. But when I say it is acting as an interpreter, it's not doing the job of actual interpretation, actual conversion from bytecode to assembly code. It is kind of loading the PVM, and PVM is going to do the rest of the job. So that is how it goes. Okay, I think you got the point here, Sagar. So point here is, whenever you are doing the job, the PVM is going to convert your code from bytecode to assembly, and loading PVMs is the job of Python 3. Okay. Okay, fine. Digvijay, your question, as the Python is using compiler and interpreter, but it says the interpreter only. Why? Digvijay, I think I mentioned that yesterday as well. When I said that Python, I said that Python is a kind of interpreted language, and I put a kind of, asterisk mark here, So generally it says it is an interpreted language, but when you talk about interpreted language, that interpreted language behind the scene uses the compiler in the first place, and then it goes for interpreted. That's the reason why it is a little bit different than the others. Okay, so Digvijay, that's the reason I put this asterisk mark there. It's not completely interpreted. It is a compiled plus interpreted. It's similar to Java. It's similar to other languages where the virtual machines is used. Okay, next, Rajendra, question. Name error, name hello world is not defined in the PyCharm after running the code. Must be having some code issue. So look at the code and probably you will see that. It's very simple. Print. You have to see whether you are doing something wrong there. If it is something wrong, then probably your code needs to be checked. I don't think there is any problem with the PyCharm. There is a problem with the code. So check and see whether the code is working fine or code is right. Okay. So that's your question. So interpreter is just feeding the code into the PVM. Yes, interpreter, not interpreter, should I say. Python 3 is feeding the code to the PVM, and PVM is going to do the actual translation. Okay. We'll be sharing the images. Of course, Akshata, I'll be sharing all the images. I'll be sharing all the things with you. So yesterday I shared this file. I'm going to share it one more time because today I'm editing it again. So every day, whatever diagrams I'm going to draw, whatever code I'm going to write, everything will be shared with you. Okay. So don't worry about that. Okay. So probably I hope everything is clear here. Guys, can you please give me the confirmation whether have you understood the story here? Have you understood the comparison between C and Python? Okay, at least couple of years, that means you have understood it. Very good. So if you have understood it, please keep this thing in your mind all the time when you are writing the Python code. Python is not a pure interpreted language. Python is a compiled plus interpreted language. So there is a compilation and there is an interpretation. So remember that. Okay. So when I say compiler is required, because you see that in the first phase, there is a compilation, and in the second phase, it's an interpretation. So we need a compiler. So if we need a compiler, we need to use a couple of them. So if you go for Python, there are a bunch of compilers available. That's where the compilers come into picture. So Python has many different versions. Python has very different compilers available. One of them is called as a C Python, which is kind of developed in C. So maybe you can say the compiler, the Python compiler I talked about last time is developed. Python compiler is developed in C. That's why it's called as a C Python. Then there is a PyPy. The Python compiler is itself a Python program. There is a Jython developed in Java. Iron Python developed in another language called as Iron. Nutica. It's another option there. PyJS is developed in JS. The compiler itself is developed in JS. R Python developed in R language, and there are many different options available there. Now, henceforth, whenever I say we are using or we are developing a Python application and Python is using compiler behind the scene, we are referring this particular version of Python. So when you are using Python, when you already have downloaded that Python from Python's default site, this is the one, it uses C Python. It does not use any other, but it uses C Python. So henceforth, please remember, when I say Python is having a compiler, I'm referring to something called as a C Python. So C Python is the default one which is used all the time when you are developing your Python applications, and that's the reason why we are also going to use the C. So when you talk about the compiler here, by default we are going to use the C Python. The standard version is called as the C Python, which is what most of us use when most of us download from the official site. And henceforth, when we say we are using Python, it is always the C Python. Please remember that. So this is the story we talked about. Let us quickly see what is a C Python, and then we'll start writing the actual code. So C Python is the default and the most widely used implementation of the language. So when I say implementation of the language, that means this is the compiler which is going to compile your code to the bytecodes. And this is by default used when you are downloading that Python from the Python's official website. One of the reference implementation of Python language is the C Python, written in C and Python itself. Can be referred as both compiler and interpreter. I hope you now know why it is referred as a compiler and an interpreter. I mean, how it is doing the job of compilation and interpretation. For more, you just look at this diagram and you will see on the left hand side it is working as a compiler, on the right hand side it is working as an interpreter. So this is how it is going to do the job. Okay. How can you use another versions? To use another versions, you have to download those versions from the different sites. So search for PyPy or search for Jython or search for Nutica, and you have to download it, and then you have to use their specific instructions. So Siddharth, if you really want to do that, you have to download the different versions from their own sites. Okay. Okay. Now we already have said hello world. How does it work? And probably we already have seen that. So quickly see what happens behind the scene. We'll just quickly go over it one more time. So hello world program, how does it work? Python is not a compiled language. It's a misconception. Python is a compiled plus interpreted language. People generally say that Python is only an interpreted language. Misconception again. Python is both compiled as well as interpreted language. C Python has the compile base. In a sense, C Python converts your Python code into bytecodes. So Python compiles into bytecodes. CPU cannot understand the bytecodes. We already have discussed that last time. So we need an interpreter to understand and execute your bytecodes. This is nothing but the Python virtual machine. So the interpreter is nothing but the Python virtual machine. To load that code into Python virtual machine, we use Python 3 precisely, and PVM does the conversion or does the translation. So basically the PVM here is going to convert your bytecode, let me mention that here, to the assembly code. To the assembly code. So this is how it goes. So whenever you are talking about the interpreter, this is the interpretation, this is the conversion. The conversion actually takes place inside the PVM, and you use Python 3 to load your PYC code inside the Python virtual machine. Okay, so Python virtual machine or PVM, it itself is written in C. That's the reason why it is so fast. That's the reason why it is platform dependent. Now you must have got the point, like why I said that this is a platform dependent. So why it is a platform dependent? Because this is designed, or this is developed in C. Whatever is designed in C will be platform dependent for sure. We already have discussed that earlier as well. So this is the C code, which is kind of the language used for designing, or language used for writing the PVM, and that's the reason this is platform dependent. So it compiles your bytecode into the assembly code or the machine level language. Machine level language is nothing but your assembly code. It emulates the machine or CPU. In a sense, your code is not converted, or your Python code is not going to get converted directly to assembly. The Python code gets converted into something like a bytecode. That bytecode is what getting converted into assembly by using the PVM. It executes the bytecodes similar to the way the CPU executes the machine instructions. So when you say PVM, it's called as a virtual machine because it has a virtual CPU that can understand the bytecode. So if you just want to compare both of them, we are going to explore more on this topic later. I'll tell you the exact architecture of it later when we talk about the PVM towards the end of the session, not today, but towards the end of the course, because at that time you must have got the maturity, or you must have got the you must have understood how the Python different features works, and at that time I'll talk about the Python virtual machine architecture one more time. But just to start with it quickly, I'll say that this is the CPU, this is my physical machine, and this is the CPU. I'm just calling it as a vCPU. This is something called as a virtual CPU. To be precise, this is not required because this is not a real machine. This is a virtual machine. So probably this is nothing but a physical machine, and this is nothing but the virtual machine. Precisely, this is the Python virtual machine. Now in physical machine, when you talk about the CPU can understand assembly language. In Python virtual machine, the vCPU stands for virtual CPU. It can understand something called as the bytecode. So this understands the bytecode, and that understands a assembly code. And that's the reason why when you are using something like a PVM, we have to load that .pyc inside it, and the pyc is having all the bytecodes into it. Now the Python virtual machine spits out all the assembly code. Precisely, I can say something like this. It can spit out all the assembly code, and then all the assembly code will get loaded right inside the physical machine. So this is the assembly conversion. So vCPU's bytecodes converted into the assembly code, which could be, which can be understandable by your physical CPU, and the physical CPU is going to do the actual execution. So that is how it goes. Okay. Who's that, Adesh? Bytecode is OS independent. Yes, bytecode is OS independent. So here assembly code is the CPU dependent. Similarly, bytecode is also CPU dependent. But which CPU dependent? This is the virtual CPU dependent. This is operating system independent, but that is virtual CPU dependent. Can we run the bytecode of Linux on Windows? You cannot run the bytecode from Linux to Windows directly because you need a Python virtual machine. Python virtual machine is platform dependent. So don't worry about the bytecodes. Bytecodes will get converted into the assembly code by your Python virtual machine. So ultimately, even if you want to execute the PYC directly, you won't be able to do that. You have to use a Python virtual machine in between. And that Python virtual machine is going to do the job of converting the bytecodes into assembly code, and then it is going to execute your code. Okay, so probably Adesh, this is how it works. Exactly. Thanks for confirmation. Vipin, Jython is not written in C, right? Then how it is dependent? Jython is not written in C. Jython is written in Java. So basically, that the story will be same. It's like the compiler you are using, the executable you are using, that's Python's compiler and Python's interpreter, is not written in C. It is written in JVM. It's written in Java. It requires its own JVM. Okay. And Vipin, we don't have to worry about that right now, because when we say Python, and it's not like us, when we say Python in the real world, we always use C Python, because C Python is the standard implementation. Generally, whenever people use Python for their own use, they by default use the default version. They by default use the C Python. Okay. So we don't have to worry about how it works, and that's the reason I'm not even going to focus on that, because if I try to talk about this, then it will take another couple of hours, because every single implementation of Python is a little bit different than each other. So we don't have to worry about that. We have to worry about only one, that's the C Python. Okay, Akshay, your question? आपका वॉइस ब्रेक हो रहा है और वीडियो भी स्टक हो रहा है. I can't do anything for that. Maybe please check your internet connection. I hope I'm audible and I'm visible and my screen is also visible to you. Guys, is that okay? Are you able to see me? Are you able to hear me? And are you able to see my screen clearly? Okay. So please check your internet connection, sir. Can't help there. Okay. I think that is it then. I mean, this is the kind of fundamentals that we wanted to cover, and it's good that we are covering it on a couple of first days. So it's better do it earlier, I mean, than doing it in the later stage. Rajendra, you are asking me to stop video. I can't, and I don't want to. There is a reason behind this. Since these are online sessions, you will feel, at least you will see me right now. But later on, when you see this video one more time to revise the concept, you will see that there is no person in front of your screen. Someone is talking in the background, and you will see only static screen, and you will feel literally bored. So what I want to say here is, right now also I don't want you to feel like the voice is coming from somewhere in the background. So it's better at least you see something is moving. The entire screen is static, at least I am moving here. Okay, so you'll not feel bored. Okay, that's the reason why I'm using my camera here. Okay, so actually speaking, right now, even though it is taking a little bit more bandwidth, and if you are saying like it is stuck somewhere, it's okay. Later on, when I upload the video, you can also go back, revise it, rewind it, and probably that will help you there. Okay. So enough about this today. I think this is a kind of basic, and we already have discussed all of this. Please do not forget this diagram. I'm going to refer this almost every single day when we write the code. Okay, so let me close this, not required now. We'll continue with the next discussion, and we'll start writing the actual code. We want to do something which is kind of, useful. So let us start doing it now. So we said that we are going to use the PyCharm to write the Python code, and that's what we are going to use now. And this is where we'll start writing the code. We have created a file that's page1.py, and probably right here I've written a very, very simple print hello world. So in that print hello world, probably you can see that we are kind of simply spitting out something on the console. So now we'll start writing a better code. Now, before we start writing the better code, let me go back here and let me see whether I have the notes open here somewhere. I already have the notes for you. So probably right here. I'm going to share all of them to you. No, that's a JavaScript. It's not for you. This is Linux, again, not for you, not for you. Where is the Python? Do I have it? Yeah, here it is. So this is the Python. I'm going to share all of these things with you. And rather, before I say I will share, I'm going to share it right away. So probably you will get a chance to look at the PDF file, and probably I'm going to share that right here. Just give me a sec. Where are you? Just a sec. Python dot PDF. Here is it. Okay, so I'm going to share that in a second. Probably you will see that right there on your chat as well as on your WhatsApp group. Let me open the WhatsApp here. Not here, on the screen, and I'll share on both the places. Okay, here it is. Just look at your chat and confirm whether you have received it or not. Just give me a sec. Okay, I just have shared it on your chat. Just go there and see whether you are able to see that Python.pdf there. And I'm going to share that on your WhatsApp as well on Python's group. I just have put the code there. This is the one. Shared it on Python and shared it on Combo. I don't know. Okay, so hopefully you must have got it now. Okay. Yes, good. So now you just open that file, and probably you will see all of the things which I'm going to use here. So you will see every single thing inside that PDF file. So the PDF file contains all the notes, I mean, all the topics that we are going to cover in depth. And this is something which I have prepared while while conducting the course. So this is completely live. So maybe if required, I'm going to modify the code, and if I modify the code, definitely I will share the updated file whenever I modify the code. Okay, so don't worry. Okay, next there is a question. Abhijit, are we going to use Jupyter? Not today and not in the first couple of weeks. We are going to do it towards the end of it, where I'll show you how to use a Jupyter, how to write the code, along with another syntax called as Markdown. Okay, I'll talk about this towards the end of it. But yes, we will, not in this, but in the last week. Chinmay, can you please add me in a WhatsApp group? I think Chinmay just sent you a request to maybe Pradna ma'am or maybe to Smita ma'am, and probably both of them can add you. Okay. Another one, Swapni Santosh, when will we get the recordings? Today is my first day and we'll have the dropout, blah, blah, blah. Okay, no problem, Santosh. Right after this, it will take an hour or two, and probably it will be available around 1:30. Okay. So once we are done with the session, I'll create it will take some time to record, to create the MP4 file. It gets time, it takes time to convert that in right format, and probably by 1 o'clock, it will be ready. So you just go to the student portal and you will be able to see that there. Okay. Good. Okay, you cannot see the PDF file, Amruta. I just shared that on your chat there. Just open the chat and you will see that there. Download it directly in the chat. So go to the chat and download it. Okay. Okay, so probably I'm just going to go back and open that PDF file, or we can, I can open this one as well. This is the one which you see there. I just shared that. It's almost like 50 pages. There are many things here. So probably if people who want to go for the advanced topic, they can directly start looking at them as well. Okay. Tejas, you are going to get one. Invitation there for student portal. So go for the student portal, and then probably you'll be able to see that. Okay, you definitely will get the instructions later. Probably you must have done that today. I mean, you must have joined it today. That's the reason why you are not able to see that message. But definitely you are going to get one email, or you will get one WhatsApp message, and there you will see it again. Okay. Okay, are you going to provide all the data on the Git? Yes, I will. Starting from today, everything will be provided in the Git as well. Yesterday, I was waiting for all of you to confirm your the GitLab username. I think all of you must have already updated that. So starting from today, you are going to get that update, or you are going to get all the notes and all the code from the Git. Okay. Okay, so enough about this. Let us continue with the next point and see how it can be done. Are we going to learn how to integrate with the atoms and regex? Of course, regex is one of the topics there. Of course, yes. Ramesh, we are. I mean, this is the way we are going to find out different things from different files or different data. So we have to see a regex. This is one of the topics what we have to cover here. Anyway, so now you know the basic things. Let us start writing the code there. We already have discussed all of these things. This is just theoretical part. If you get a chance, take a look at this, and probably if there is some correction, just let me know. I mean, we have done that while doing the code, and if you find there is something that to be updated, just let me know. I'll do it for you. Okay. Now we'll start writing the code. This is something we already have discussed earlier. Now we'll start writing the code. Now to start writing the code, the very first thing we want to write is, or we want to start with, is a variable. Now generally when you start the language, why do you use the language? Use the language because you want to convey your thought to the machine or to the CPU. Now when you say you want to convey your thoughts, or you want your machine to do something for you, you have to write the instructions. Those instructions are called as statements. So when you are in any language, when I say any language, it can be C, it can be C++, it can be any compiled or interpreted language. You generally write the statements. Statements are the ones which are going to get executed and which are going to provide you the final output. But in the statements, if you want to change some values, you have to create different variables. So when you are writing the programs, your programs will be full of different variables, different statements, a different piece of blocks and stuff like that. So out of them, the most important concept that you have to start with is something called as a variable. But variable, function name, later on class name, all of them generally known as the identifier. So let us start with the identifier first, and then we'll start creating or declaring our variables and other stuff. So what is an identifier? Identifier is nothing but a valid word which is used to perform an action. So probably if I want to say I have a variable to declare. So if I say variable is equals to value or num is equals to 10 or 100, that means num is an identifier which is going to do something. What it is going to do? It is going to hold a value something like 100. So that is the job of a num. The job of num to hold a value 100. So this is an identifier which is going to perform an action. This is called as an identifier. Now, when you are in Python, there are many type of identifiers you can use here. For example, a variable name is an identifier. A function name is an identifier. Later on, class name is again an identifier. So whenever you are writing an identifier, please remember a couple of rules. You cannot start a identifier's name with a number, which means one name is not a valid number or valid identifier. First name is not an identifier, valid identifier as well, because it has a special character like space. So whenever you are in Python, you cannot start any identifier name with starting with the number. This is not possible. So probably you cannot use the special character like space as well. If you want to use a special character, then only one is allowed, and that is underscore. Why am I telling you this? Because now I want to start declaring a variable and see how it is different than the other languages. I think print hello world, that's over now. Let me delete that and we'll start writing the code right here. So probably I'm going to start declaring my first variable. Now how to declare a variable? To declare a variable, I need an identifier. So probably I'm going to say num is my identifier, num is my variable name, and I want to store a value of 100 there. That's it. It's as simple as that. Again, please do not compare C with any other language like C++. Do not compare Python with C or C++, because that will again make the things complicated. Don't ask the question like in C we do this, because that is the way C works. We are using Python now. Python works a little bit differently. Now, when you declare a variable, by the way, what you see here is a variable which is holding a value 100. Now, when you are in Python, there are different statements. As I said earlier, one of the statements is a comment. Comment is also a statement. This is also a statement. The statement is where we are declaring a variable. So you can say this is the variable declaration statement. But I want to say that this is a variable, and that's the reason I want to add a comment. To add a comment, you can use a hash. So hash is the way you are going to add a comment in Python code. So maybe I'll say this is a variable. Now, when I say variable, this is the way we are going to declare it. In Python, variable declaration is very simple. All you need here is the variable name equals to the value you want to store in that variable. It's as simple as that. There is no data type that you have to specify explicitly. If you can recall something, I said that yesterday, Python is a dynamic language. When I say dynamic, here the data types can be decided dynamically by the Python. In a sense, even if you want to make it something like integer, or if you want to make it like string, or if you want to make it like Boolean, you can't do that. You have to say num is equals to 100, and Python will decide what is the data type of it. Now, can we see the data type of it? Of course, yes. I'll show that in a minute. But let us start with the declaring that variable num equals to 100, and I want to first see the value of that num on console. How do we do that? You do that by saying print num, as simple as that. Again, here we are declaring a variable. So this is called as a variable declaration. In the variable declaration, the variable name is num, the variable's value is 100, and here we are trying to print the variable's value on console. Will it run? Give it a try. So probably let me say run, and probably you will see 100 here on console. The 100 here on console means you are printing the value of num, and that really works. As simple as that. Yes, so this is the way we are going to declare the variable. Now please remember, though it looks like a number, though it looks like an integer, I cannot just say integer num equals to 100. This is invalid syntax in Python. So in Python, you cannot declare a variable explicitly. You have to declare it something like this. And that's a reason, if you look at your notes, I mentioned that there is only one way to declare it. So probably if you just go back here, you will see this is the way you are going to declare a variable. You need a variable's name, and then you need the variable's initial value. So probably you will see an example, num is equals to 100, and that's it. This is the way you can do it. So probably I'll just add one more statement here, and I'll say that the variable cannot be declared like C. Variable cannot be declared explicitly. Explicitly in a sense, you cannot you cannot say the data type of that variable is integer, or you cannot say the data type is equals to string. Everything will be done automatically by Python. So whenever you are declaring a variable, this is the way it is going to do the job. Okay, so if it is going to do the job, let us see here what happens now. So when I run my code, I got the value equals to 100, but I'm a little bit confused here. Like if it is declaring a variable must be having a data type associated with it, isn't it? If it is having a data type, how can I get it then? I mean, really, is Python going to assign data type to it? Yes, Python is going to assign a data type to it. And that is the reason in Python, all the data types are something called as inferred. Let me repeat myself. When you are in Python, all the data types are inferred. So if I just go back somewhere here, I already have mentioned that in Python, all the data types are inferred. What do you mean by this word inferred here? The word inferred, that simply means all the data types will be automatically assigned by Python. So Python says, hey, if you're saying that it is equals to 100, for me, 100 looks like a number or 100 looks like an integer. So it by default will assign an integer data type to num. You cannot do it explicitly. Python will do it implicitly. That implicitly assignment of a data type is called as inferred. So here, all the data types are inferred, or all the data types are getting assigned by Python implicitly. So Python, it is going to assign the data type automatically by looking at the current value of the variable. So if the current value of the variable is equals to number or is equals to integer, your variable will get a integer data type, something like this. So let me come back here and try to put the data type of that variable. So to print the data type of that variable, I'm going to use print. To get the data type of a variable, you can call a function called as a type, and then you can pass the variable like num. So here I'm trying to get the data type of num, and I'm trying to print that by using a function print. So probably here we are creating a function, we are calling a function print, and we are passing one more function's output, that is a type. And if I say run, probably you will see the data type of that num is equals to int. Ignore this for a couple of days till we see object-oriented programming in Python. So just ignore that. Just read this part here. This is something called as an integer, and this integer is by default assigned by Python. It's not like we have done anything for that. We just said that this is a number equals to 100, and behind the scene, Python has said like, oh, 100 looks like a whole number, and because it's a whole number, it has assigned a data type to integer. That's it. This is the way Python works. Very simple language. Now, when you talk about printing some values on console, it works. I mean, I see the value of num here. I see the data type of num here. But sometimes I don't want to see only value. I don't want to see value alone. I want to see something like num equals to value of num. If I want to do something like this, see how it can be done. So probably I'll put this in comment. By the way, if you want to comment multiple lines, go ahead and select them first, and then use control / and control / to uncomment them. So it's kind of a toggle. Control / is the way you are going to comment or uncomment. It's a toggle, and that is another shortcut you can use all the time to comment or uncomment the statements. Okay, so what I want to print here is like my output should be like this: num is equals to 100, which means there is some static part like num equals to, and there is some dynamic part which is the value of num. So if I want to write a code like this, then probably I can say print inside this, see this and try to understand that. Today or maybe for a couple of days, just get it. This is the only way to do it. Later on, I'll explain when we go to the string part, or when we go for the string formatting topic, then we'll explain what do you mean by it. Right now, just say this is the way it has to be used. So start using F. F stands for formatted string. What do you mean by that? We'll talk about that later. Today, just see how it can be used. So print F, use either double quote or single quote, and say num equals to. If I say num equals to num, see what happens first. If I say run, probably you can say num equals to num. It's getting printed as it is. So num equals to num. To be precise, I want to keep that num equals to as it is, and I want to replace that num with its value. So for me, I want to differentiate this num from this num. For me, this num is a variable, and this num is a kind of word I want to print there. So to differentiate any word from a variable, just put that word in curly brackets inside the double quotes, something like this. So you start with f, you say num equals to, and in curly brackets you can say num, and then it is going to print the way you are looking for. So I was looking for num equals to 100. You see num is equals to 100 now. This is the static part. This is the one which we hard coded saying num equals to, and this is something we are reading the value of num. This is the way you can write a code which is going to read the value of a variable, and we'll put that in console by using some hard coded values or some hard coded code like this. Okay, so this is going to tell me that this is the variable num which is having a value equals to 100. Now at the same time, I also want to see the data type of it. No big deal, just put a comma and say the data type which is equals to, again use curly bracket and write the code here. So maybe I can call a function, the Python, the type function which we already have used last time, and I can get the value of it and put that in a same string. So probably I can go back here, right click and say run, and probably you see that num is equals to 100, the data type is equals to integer. The F here stands for formatted string. We'll talk about that F later in a sense when we go to a topic, something called as a string formatting. At that time I'll talk about what that F stands for, how that F really works here, and what are the different options available. Today just say this is the way you should print the values when you want to get some string along with some variables value. So this is the way you can do it, right? Who's that? Adesh. This is the way you are going to use it in different languages. Here this is the way you can use it. In Python there are different ways to do that. This is one of the better ways. Okay, so Adesh, though this can work or this can be the one of the ways, but this is the preferred way because now I'm going to use num is equals to, and then I can put the value of num. I can say data type, and I can also put the data type of that num right inside the same string. Okay, can we also use a single quote? Yes, just wait for a minute. Who's that? Just wait for a minute and probably you will see it. Okay, so this is the way we are kind of declaring a variable, and this is the way we are kind of printing the variable on screen on the console. That's it. This is the way we are doing it. Now probably what I can do here is I can continue, and I should rather, I'll put it right here, and I say that is not required. I'll say that this is a kind of integer. This is an integer because we are storing the value 100 here. Okay, now let me go back here and say I have another variable called as a salary, and let's say 10.56 for example. Now when you say 10.56, this is a kind of a decimal value. Now let us see what happens when I want to get the value of it and when I want to print the data type of it. So probably I'm going to again write the similar code. I'll say print F. F stands for a formatted string. Inside double quote, I'm going to say salary, which is equals to, again in curly bracket, I'm going to say salary, comma, the data type which is equal, the data type which is equals to the type of a salary. So probably right here I'm going to print the salary's value, and along with it I'm also going to print the data type of that salary. So probably again right click, say run, and you will see the salary value is 10.56. Because this is a dot, because this is a decimal, it is telling me that the data type of it is equals to float. So basically this is an integer and this is a float variable or float data type. See how many data types are supported in Python. So one integer is going to store the whole numbers. Two, float is going to store the decimal values. So this is how we can do it. Okay. What if you want to remove F? Will it print or not? Give it a try. Aisha, give it a try. If you remove that F, nothing is going to work. It is going to print it as it is. In a sense, whatever we have written here, it will be written as it is. And that's the reason F is important. Okay. I'm going to talk all about this in little more details later. Okay. Kshitish, no, it does not allow double. It just allows only integer and float. Okay. So basically there is an integer which is going to store the whole number. This is going to be the float. Float is going to store the decimal numbers. Now the next one, let's say this is the name. Probably I'm going to store name of a person. So for me, the name of a person is a Steve, for example. Notice it, I'm using a single quote here. Maybe I'll make it little bit different. In that case, I'm going to say first underscore name, and then I'll say Steve. Now, generally there is a saying. The saying says, when you are in Rome, do what Romans do. Now, when you are in other languages like JavaScript and PHP, for example, you can use a camel case. Camel case is where you start with the lowercase and every single meaningful word will be having a uppercase like this. But in Python, we prefer using underscore. So this is the way I can declare a variable in Python. This is the way I can declare a variable in JavaScript and other languages. But here we prefer using underscore, and this is the way we are going to declare all the variables and the functions like this. Okay. So I have a variable, let's say first name, and I want to see what type of variable I'm declaring here and what is the value of it. So probably I'm going to again say print f, don't forget that f. I'm going to say first name, which is equals to, in curly bracket, I'm going to say first name, comma, again the data type, like what we said last time, there is a type of first name. That's it. So let us see what is the output here. Now, henceforth, I'm not going to say right click all the time. I'm going to use a shortcut. For me, it is a control shift R. For you, just take a look at it. When you say right click on that, you will see the shortcut right here. So probably this is the shortcut, you use it. And it tells me that because I'm using a single quote here, it is telling me the data type of it is str. Str means it is a string. So probably I'll say this is an str, or str is nothing but a string here. Now, again, you're in Python. So probably if you want to declare another, let's say last name, I can say Steve and Jobs. Notice it. Last time I used single quote. This time I'm using double quotes. Now let's see what happens. If I use a double quote or double quote and single quote, is it going to give me different data types? See quickly. Maybe I'll say something like the last name, which is equals to, in curly bracket, again the variable name, last name, and then the data type of it. So maybe I can say data type, which is equals to the type of last name. That's it. Just to be precise, when I use a single quote or double quote, it doesn't matter. It ultimately gives me a variable of type string. So both the first name and the last name are of type str. Okay, this is the way we can do it. Now you must have noticed here that whenever you are declaring a variable, you have to initialize it. You have to pass the first value. You have to pass the initial value. You cannot declare uninitialized variable in Python. So probably Adesh, that answers your question. You cannot declare uninitialized variable. So variable must be initialized. So here you cannot write a code like C where you can say integer I and leave it hanging. So here it is not possible to do that. And again, believe me or not, declaring a variable without initializing it, it's not a good practice. So that's the reason Python uses a best practices by default when you're writing the code. Anyways, so I have a single quote, I have a double quote, and both of them gave me a kind of string. Now let me go back here and say I want to print address of a person. So if I want to go for that, I'll say this is an address. But again, you must have noticed here, first name and last name, both of them were single words, or both of them were one line inputs or one line strings. But address generally spans across couple of lines. You write your home address, you write your building name, you write your, let's say, maybe corner, gully, mohalla, there are so many things you add in your address. So if I want to go for this, how do I do that? Now remember, both single quote and double quote are useful when you are using a single line value. So string, single line value, string line value can be used by using single quote or double quote. But when you are going for multi-line, this is also a string. It has to be a string, but in my case, I'm going to make it multi-line value. So if I want to go for multi-line value or multi-line string, then instead of using single quote or only one double quote, I'm going to use triple double quotes. This is the special syntax in Python where you can have multi-line string in a variable. So this is triple double quotes. Notice that this is the triple double quote, and right here you will start writing the code. For example, this is H105. For example, maybe somewhere near Sinhagad Road, for example, again, comma, Pune, that's a city. Then we can say 411041, blah, blah, blah. And then this is the Maharashtra, and so on and so forth. So basically, you can say whatever you want to add here by spanning it across multiple lines. This is the way you are going to declare a variable which has value spanning across multiple lines. You know, I can simply go back here and do the same job what I've done earlier. So here I'm going to say This is an address. So this is an address, which is kind of an address variable. And this is the data type. Data type, which we again going to print by using the type function. And I'm going to pass the address there. That's it. Again, control Shift R to run this code. And you see that all of them were single line input. This now is a kind of multi-line input or multi-line string. And again, the data type is equals to string. So probably now you can say this is the way it is going to do the job. So please make a note. This is a triple double quotes and this is also triple double quotes. So this is a combination of 3 quotes, and this is the way you are going to span your string across multiple lines. So both single quote and double quote can be used for single line, but when you are using a value which is going to span across the lines, or if it is a multi-line, then you should go for triple double quotes. That's the way you can do it. Okay. This is the way you can do it. No, you cannot use a triple single quote. You have to use a triple double quotes. That's the way it works. So Sachin, this is the way it works. Okay. Okay, so now you know that this is the way it can be written as a single line or as a multi-line input or multi-line string. I think we know now there are 3 data types we have seen so far: integer, float, and the next one we have seen just now is a string. Okay, now sometimes it happens. Let's say, for example, you are maybe in the next year or in a couple of years, one more election is going on. So in that election, if you want to see your eligibility, so you may be going to appear for an election, or you may not appear for election. So you cannot cast your vote, or you can cast your vote. If it is the case, so probably I can say something like a can vote. I'm sorry, can vote is equals to something like, in this case, either it can be a true or it can be a false. Now, if you're coming from different languages like C++ or maybe Java, there you use something like a true, where T is a small. Here, T is capital. So whenever you want to say true or false, you have to say true with T capital or false with F capital. So this is the way it works. Remember, true and false in case of Python is going to start with the capital letter. This is predefined value. And hopefully I already have mentioned in your so-called notes there all the predefined values, and this is one of the predefined values, true or false. And both of them are going to give you a data type called as a Boolean. In short, it's called as a bool. Let's give it a try. Again, as usual, I'm going to say F can vote is equals to can vote, comma, let's say data type, which is equals to, again, the type of can vote. So probably when I say run, you will see on the output side, this is can vote, which is equals to true, and probably data type is equals to bool. So bool stands for Boolean. And when you say Boolean, there are only 2 values. There are only 2 values possible. One is true and the other one is false. So this is kind of a Boolean, not capital, but the small capital. This is the bool. That's another data type you can use here. Okay, in Python, we can't declare uninitialize the variable. Means Python don't have the default values. No, Python does not have any default value. You have to initialize the values for you. There is no way you can declare uninitialize the variable there. Okay. Is there something called as a new line in Python? Wait, I'll talk about it. Utpal, how to go now? I'll catch a recording. Okay, you have to go now, no problem. You can, and you can catch the recordings later, no problem. Thanks for letting us know, Utpal. Very good. Okay, so now we see there is a data type called as integer, there's another data type called as float, there's another data type called as string, and there is now one more data type called as a Boolean. Now, other than this, there are 2 more data types. One is called as a complex, which we are going to see later, and another one, which I can't talk about it right now, this is called as an object, because to understand object, we have to go for object-oriented programming, and unless we go there, we'll not be able to create an object. So this part and this part is little bit kind of kept reserved for now. We'll talk about them in extensive details later when we go for OOP. So for now, we are having 1 integer, 2 float, 3 str, 4 a string, 4th is the Boolean, and 5th one is nothing but complex, and 6th one is nothing but object. These are the default data types provided by Python. Please remember, in Python, you cannot declare your own data type. You have to rely on Python. So Python is going to do that automatically for you. And whenever you are declaring a variable, you have to initialize it. Once you initialize it, probably Python will see the initial value, and it will automatically assign the right data type for your variable. So that is how it goes when you are declaring a variable in Python. Okay. How to receive an input from user without initializing the variable. We'll talk about it. There is a way to do it. So we'll talk about it. Don't worry. This is where we just have begun. Okay. There are many things we have to see. Can you reassign them with the string value? Yes, you can. All of them are variables. So basically, if you want to change the variable value, you definitely can. So probably if you want to say something like num is equals to 200. So see, first value of num was 100, and now the num's second value is equals to 200. So basically, when you are declaring a variable, it's a variable. What is a variable? A variable is nothing but a placeholder. It is going to hold some value. And if it is going to hold some value, you can keep on changing that value as per your requirement. Okay, so that is how it goes. So probably whenever you're talking about something like this, you will be able to just change the value as per your requirement. So probably you can get some values from user, you can perform some operations, and then you can play with them. Okay, that's how it goes. Shubham, can we use a derived data type? No, you can't. Derived data type, if you are saying something like a user defined data types, yes, you can, but not right now. For that, you will have to understand what is a class. There is no structure here. There is a class. We'll talk about it later. Okay. I mean the num equals to sunbeam. Give it a try and you will see. Yes, it is possible to do that. So Siddharth, it is possible. Just give it a try and you will be able to see that it will never give you any kind of error like this. Okay. Ranchit, your question, how can we print the negative and the positive values and the data type? Negative and positive values, you just go back here and pass the negative value, -100. So probably when I say run, it is going to tell me that this is the -100 here. If you are using positive and if you want to print the plus sign there, for that you have to wait. Remember I said earlier, we are having one more topic. We have to discuss one more topic later in details called as the string formatting. There I will talk about how to show the positive symbol, how to show the negative symbol, and bunch of other formattings there. Okay, guys, I can't show you every single thing on day one, isn't it? There are few things that we have to learn step by step. If you start looking every single thing on one single day, believe me, you will not be able to learn anything. It will be a kind of a khichdi. You will not be able to get single thing out of it. So learn step by step. Go slowly. I know that there are many things here, but unless you go step by step, you will not get anything out of it. So even if you ask me the question like, how can you do this? How can you do that? I'll simply tell you, just wait, hold your patience. I know these days watching the movies and watching the other stuff, we are losing our patience because we see in the movies are teaching us only the same thing. If you cannot hold yourself, just go ahead and shoot it out. That's the reason why we are losing our patience day by day. Don't do that. Have your patience, learn step by step, and believe me, you'll be able to get every single thing. Don't be in hurry or don't be in rush. Nothing is going to get fruitful out of it. Okay, so sorry for that, but this is the fact. Okay. Web series is the reason. I know, not only the movies, web series, TV shows, and whatnot. Anyways, coming back to the point, it seems like the Python is a case sensitive. It seems like it is a case sensitive. So basically, when you are declaring a variable with the num and the num, both of them are different variables. So this is capital N and this is the small n. Both of them are different variables. Okay. So this is the case sensitive language. Not only Python, many of the programming languages like C, C++, Java, JavaScript, all of them are case sensitive languages. Python does not have any entry point functions. So all these declared variables are global or having some scope. Again, wait, later on when we look at the function, I'll talk about the global scope, local scope, and inline scope. I'll talk about this, but again, not today. We'll take some time. Okay. Anyways, so now we started looking at the different data types and different variables, declarations. Now you can see how many data types are supported and how to declare them, how to get the data type of them, and how to verify whether we are declaring a variable and whether we are getting a data type associated with it. Very good. Now, starting from the next point or starting from the next program, the code length will get increased a little bit. So what I want you to do here is, I want all of you to log into your student portal. So probably if you just go there, log on to your student portal, probably you know where it is. It's a students.sunbeaminfo. So right there, 29141, and the password for me is this. Yep. So log into your student portal and do it along with me and see whether it is okay, whether you are able to see it or not. Now just give me a second for that. I need to add an entry for myself because I've added the entry for you. So this is the day one we are writing the code. So better we can clear this, and starting from tomorrow, you can directly start writing the code and copy pasting the code along with me. Okay, just give me a sec. Let me simply come back and copy this for me. I just copied that only for you. Here it is. Okay. Okay, so what I want you to do here is when you log into your student portal, you can go to online sessions. For me, there are multiple entries, but for you, there will be only one entry. So if you are on that batch, that's a Python -O-4. So there you will see an entry like this, something like Python. Maybe this is today's date, 2nd September. I don't look at the timing and all these things right now. Just look at this entry, and on the last column, you will see an option called as a code. So what I want you to do here is just click on that code and you'll be able to see what exactly I'm doing on my machine. So probably you see I'm in the day 2 directory. And if you look at the day 2, this is the page 1 I was writing, and you see the code directly like this one. So probably if I put it right on the right hand side, and if I just go back and put it on the left hand side, and if I modify this code, see, the moment I modify this code, you will see that in real time. For example, I don't want to keep that. Just I'm going to delete this and say Control S. The moment I say save, you see the lines are getting dropped here. So this is a live code changes here. Whenever I say save, automatically you will see that right there on that screen. So basically you can copy and paste this code from here, literally right click and say copy and paste it on your machine instead of writing the code directly. Okay, so this is the way you can do that. Online session tab is not working for you. Online session tab is not working in a sense. Are you not able to see that code there? Not able to see that code? Who's that? Ajinkya, can you not see that code option there?
Just a moment, sir.
Can you please confirm?
Sir, Pradnyam, I'm here. So am I audible, sir?
One second. Yeah, that is, sorry, my bad. Pradnyam, you were saying something?
Yes, sir. Sir, can we proceed with this tomorrow? Because, yes, ma'am. Yes, sir. Pradnyam, I'm speaking here. Hello, sir.
I'm sorry, my bad. Pradnyam, you were saying something?
Yes, sir. Yes, sir.
Not able to hear you actually, but it seems like you are saying something.
Yes, sir. I'm saying something that can we try this tomorrow?
Okay, no problem. We are not created a batch
code utility.
Okay, fine.
Yes, sir. Yes, sir. Sir, yes, sir.
Okay, no worries. So those who can see it, probably you got the idea. All we have to do here is you can go to that code, and from there you can simply copy paste the code. Those who are not able to see, because for you we have to create a new batch, so probably it will be done today, and probably starting from tomorrow you'll be able to do that. Okay.
Yes, sir. Yes, sir. Thank you, sir.
No problem. Thank you very much. Okay. So for now you can write the code for a code on your own, and later on starting from tomorrow you can copy and paste the code. Anyways, so now you know how to start writing the code, and now you know where to write the code and how to get it executed. Probably the time has come to go forward and start doing some kind of operations. So now we are able to declare the variables. I'm going to create a second page. This is the page 2, and right inside this, I want to create a variable and I want to perform some operations on it. So probably if you just look at your so-called notes, there I've created another point called as operators. And in that operators, we have a couple of different operators like mathematical operator, comparison operator, logical operators, and so on and so forth. Let us start with the simplest one, that is the mathematical operations. So to do this, I'm going to come back here and I'll say this is my n1 variable where I have a variable value is equals to 10, and I have another variable, let's say 20. Now all I'm going to do here is I'm going to perform some mathematical operations on it. Now when I say mathematical operations, that simply means first one is the addition. It's the simplest one. So I can say this is the addition, which is equals to n1 plus n2, just to see whether it is working fine or not. So again, I'm going to say f, this is the addition, where we are going to confirm whether the addition is right or wrong. So probably I don't have to put the data type. This is more than sufficient. So here we are trying to get the addition, multiplication, division, and subtraction of those numbers, and this is how we are getting it. This is an addition, as simple as that. Let me come back here and go for the next one. Let's say multiplication. This is the multiplication. Again, I'll say multiplication, which is equals to n1 star n2. And again, again, I'm going to say this is f string. This is multiplication, which is equals to, again, multiplication. So we are trying to write a example where we can perform all the mathematical operations there. Again, run. I'm getting the addition, getting the multiplication. Very, very, very simple. Next one is the subtraction, which is even simpler than that. I can say again subtraction is equals to n1 minus n2. Very simple. And probably I can print the subtraction as well. So maybe I can say this is the subtraction, which is equals to subtraction. Again, when I say run, probably you can see addition, multiplication, subtraction, all of them are working. The last one is nothing but the division. So probably this is the division. I'm going to say division is equals to, division is equals to n1 slash n2. Now please pay attention. This is a little bit different now. So when you say division, probably I'm going to come back and say print. Again, don't forget that f division is equals to division. And right here, if I print the output, you will see that the division is equals to 0.5. And this is absolutely right. Now, when you are in Python, the division by default, the one which I'm using here, slash division by default, is called as a true division. It's called as a true division because it returns something like a decimal or something like a float. I mean, don't call it a decimal, but it returns something called as a float. And if you don't believe me, just come back here and say the data type, or simply I can say the type is equals to type of division. I did not print the type of subtraction and addition because by default, if I'm adding and subtracting and multiplying two integers, I definitely will get back an integer. But when I'm doing it for division, it's a little bit different. So that's the reason, pay attention to this statement here. So when I say something like a true division, every time you are going to get a float, and this is guaranteed to be a float. So whenever you are using a single slash, this is called as a true division in Python, and true division always will return a float. The float will be having a decimal value. So you are going to get an accurate value there, 0.5. It's an accurate value. But sometimes because I don't want to convert that into a float and I want to get the integer or I want to get the round value, I'll go for another one. This is also a form of a division. So here I'm going to say n1, but instead of saying single slash, I'm going to say double slash. So there are two different operators in Python. One is a slash operator and the other one is double slash operator. Single slash operator is called as a true division. It is going to be a float. It is going to give you an accurate value. But a division where it is a double slash is called as a floor division. So this is a floor value of the final answer. So probably I can come back here. I can say print. This is again the division, which is equals to division. And if I take a look at the type of it, you can, type of it, you can say this is the type of division. So see the difference here. When you talk about the true division, this is going to be 0.5. This is going to be a float value. And when you talk about the floor division, this is always going to be an integer. So there is something like you are removing the decimal value. That's how it goes. So here, if you want to convert it into integer, you don't have to go for typecasting. You can simply go for something called as a floor division. So floor division is going to give you the integer result, while true division is guaranteed to give you a kind of float or a decimal value. So this is a true division, 0.5. This is the floor division, 0. It's going to remove the decimal point or decimal details out of that variable. So 0.5, where 0.5 is the decimal details, it's going to remove that and it's going to keep only the integer part of it. And that's how the division works in Python. So remember, it's a little bit different than the other languages. The other languages do have something like a division. They by default go for true division. But because you are in Python that can be done by using two ways. One is the true division, float or decimal values, and the floor division, which is going to reveal the integer value out of it. Okay. Okay. When to use type, when not to use, when we have not done the subtraction. Guys, we are using type to see whether what is the data type it is giving you. You don't have to use type all the time. So Nikita, I'm just giving you an example of what is the data type of it, you know. So you, when you're writing the code in the real world, you don't have to do that. We are learning the stuff. We are checking what type of data type it is assigning to my variables. This is generally not required in C and other languages, because there we can explicitly declare the values. Here we cannot declare them explicitly. We have to just say that, hey, division equals to n1 minus n1 slash n2. But what is the data type of it? If I want to check that, you can go for type. Okay. So the difference between true division and float division. True is going to give you the float value, and float is going to give you an integer value. Remember, integer means it's the whole value. It's going to remove the decimal part of it. Okay. As there is no double, all there be the issue with the range of the float. There is no range issue, and later on, Parag, when we talk about those data types little bit in details, you will definitely see them. Okay, so you can keep as long float as you want. There is no problem at all, because the upper limit is quite high. It's more than double, so there is no problem. Okay. Yes, Dipanjan, there is the next one. We have to look at the next one as well. These are the four basic mathematical operators: plus, minus, slash, and slash slash. Now, other than that, there is one more, something called as a modulus, or something called as a remainder. And there is another one, something called as a star star. So let's look at both of them here. So probably I want to get something like a power. So power is nothing but, for example, I think that is a too big. Maybe I can say, I want to get the power of, let's say 10 to the power of 2. So if I want to get the 10 square, so 10 to the power of 2, I can say something like this, 10 star star 2. Look at this. This is a single star called as a multiplication. And when you say double star, this is kind of power. So this is another one with which you can say 10 to the power of 2. So this is what we can say, 10 to the power of 2. Means you are getting the square of it. So basically I can come back here. I can say print and say the power value is equals to power. And I don't have to go for data type of it, because we know that the data type of integers power will be always integer. So probably when I say run, it's going to give me the 10 to the power 2 is nothing but 100. And basically we are talking about a square of it. So if you want to get the cube of it, no big deal. Just go for cube and you will get the 10's cube. That is 1000. That's it. How simple it is. You don't have to multiply it multiple times. You can just use star star, and by default, Python can give you the power of 3. Okay, so this is one, and this is the second one rather. This is something called as a remainder. What is a remainder? Remainder is something sometimes called as a modulo operator. So modulo or modulus, whatever you can say. So for example, I can say mod equals to say 10% to 2. So 10% 2 is where we are going to get the remainder of that division. So probably if I go back here, I can say f and say this is the, what's the variable name? Mod. So mod is equals to, I can say mod. So when I say run, probably I know that 10 is an even number, and that's the reason I'm getting mod is equals to 0. If it is 11, for example, so probably it is going to tell me that yes, the mod is equals to 1, because this is an odd number. And if you are dividing any odd number by 2, you definitely will get one remainder for sure. So that is the reason we are getting 1 here. So this is another operator, which is called as a remainder, or which is called as a modulus or modulo operator. So basically when you talk about the different mathematical operators, there are 4 basic: plus, star, minus, and something like a slash. But when you are in Python, there are 3 more operators provided: double slash, double star, and modulo a percentage. So when you say double slash, it is also division, but this is a floor division. When you say double star, this is not a multiplication. This is rather a power of operator. And when you say percentage, this is a kind of remainder operator. This is a kind of a modulo operator, which is going to give you the remainder of division there. Okay. Cube root or square root, yes, that can be done, but not by using any special symbol. For that, you have to call different functions. Snehal, there are different functions we are going to see later from the math library, and from there you can get all the cube root and the square root and all of this. Okay. Okay, Hanan, your question: what if we write the print addition? Will it give the same output as the print f addition? What is the advantage of using f? I think Hanan, you missed the point when I said f is used for getting the value of a variable within a string. So probably if you don't want to write that floor division, if you just want to print the division, then you can simply say print division as well. We don't have to use the F there. F is required when you want to integrate the value of a variable inside the string. So if you want to do something like this, then only it is useful. Otherwise, simply go and say print division. That will solve your problem. I guess Hanan, you are getting the point, right? We can use the we can use the len in the string. We can use the len in the string. Of course, yes. So there are many different operations we have to see, many different functions we have to perform on different data types. So as and when we move further, we will talk about all of them. There's a separate session we have reserved for only string, string formatting, string operations. So there you will see one of the parameter, one of the functions called as a len. Len is going to give the length of a string. Okay. Okay. So probably this is how we can perform the mathematical operations. Now, mathematical operations is going to be very simple. All you have to do here is get the numbers and then start doing the mathematical operations like this. Now, when you talk about the mathematical, let me just come back here and say these are all my mathematical operators. Now, there is only one operator, which is kind of operator. So there is only one operator which is going to behave a little bit differently when you are having different data types. Now, it's not going to work for different data types, but it's just only one single operator. Maybe I'll just give an example here. In this case, this is a kind of mathematical, but it is going to get used with a string as well. Watch what I'm trying to show you here. So this is a kind of multiplication operator. Again, multiplication is in star. Sorry, multiplication operator. So when you say multiplication operator, last time we said something like this. Say multiplication, we already have said that. Why am I writing it again? It's here. Multiplication is equals to n1 star n2. We said that last time as n1 and n2, both of them were integers. But now what I'm going to do here is like, I'm going to do something different. So here, I'm going to say print directly, and right inside this, I will say this is a string. The string is something like a hello, and I'll try to multiply that string by 5 times. Now, what do you mean by multiplying 5 with the string hello? If I say 5 star 5, probably you will see the answer is equals to 25. So if I say 5 star 5, the answer is equals to 25. That's because we are having two integers, two numbers there, and we are going to do the multiplication mathematically. But when you are having heterogeneous variables, heterogeneous in a sense, those are having different data types. One is a string and another one is a kind of integer there. So in this case, it is not going to do the mathematical operation. It's going to do rather a string operation. So this star is a multi-purpose. String into number will give you something different than number into number. So if I just go back and say run, you will see that this is hello, this is hello, this is hello, this is hello, and this is a hello. If you count this, you are going to see that it is appearing hello, it is printing hello 5 times, which means whenever you are using a string and if you say star 5, the string here will get repeated 5 times. As simple as that. Now, how is it useful in Python? It's very useful. For example, if I want to print a line, so probably if I just say dash and if I say something like a 20 and if I say run, you can see that it is printing 20 dashes and it is creating a very nice string, a very nice line there. So that is how it is kind of used here. You don't have to go for different loops for that. Absolutely. No loop is required, Parag. You might have done that in C or C++ or in other languages where you were using for loop to print a line of dashes. Not required here. You are in Python now. Welcome to Python. So basically, if I say I want to generate some patterns, do it in this way, and probably you will get a very nice string, hardly one single line of code, and you will get what you're looking for. So that's the only that's the only one exception. Rest of the parameter, rest of the operators will work only with something like numbers or something like a decimals. That is the only operator which is a little bit working differently than the others. So here, when you talk about the operator, this is going to get work on a string, and here this is kind of a string operator or string star operator. What does it do? It repeats this string, whatever it is, 20 times. So this is the meaning of using that star operator on a string. Okay, so probably now you know. There is one more operator that is not going to work on heterogeneous, but I mean, this can be, but generally we'll use it on the homogeneous on the string. So string plus operator. Now this is a star. We see that the star operator is kind of repeating this. Let me see what happens here. This is pretty much logical. Anyone can say that. This is a hello plus something like a world. Now hello plus world, you know, it's going to print the hello world here. So basically the string plus operator is nothing but concatenation operator. Concatenation operator, and this concatenation operator is nothing but you are concatenating those two strings together to produce the next string, to produce the last string, or to produce an output like this. I hope you are getting it. So this is an exceptional operator where you can have a heterogeneous in the sense two different values. This is the string value and this is a number value. This is still homogeneous, but it is a different way to work with it. These are not numbers, these are strings. So if you use the plus operator on strings, you definitely will get something like a string concatenation. It's very simple to understand. I know that's the reason why we're looking at it today. Okay, Vaishnavi, is it possible to print the string in a vertical direction with the print? No, there is, I mean, directly not. There is way to do it, of course, but not today. Again, it will take some time. The print function accepts a parameter with which we can deal with it, but I've reserved that in the for the other session when we're going to talk about the string formatting, where we are going to do these kind of jobs. Okay, so wait, you will see that. Okay, so now we are kind of looking at the operators, and we have finished with at least one type of operators, that is a mathematical. Now quickly we are going to look at the second type of operator as well, which is very simple to understand, and I bet you might have already guessed what I'm talking about. So I'm talking about the next one, which is a kind of comparison operators, which is way simple to understand. So probably if I just go back here and say something like n1, which is equals to 10, n2 is equals to 20, and probably these are all comparison operator. Sorry, comparison operators. That's it. Comparison is going to be very simple. Comparison means I'm just going to go back here and just compare all of these variables, all of these values. Again, 10 equals to 20. Is that the case? I don't know. I'll just check that. So 10 equals to 20. That's it. Or n1 precisely. n1 is equals to n2. That's better. And I can just put that values dynamically by saying n1 is equals to n2. That's even better. So now we can see what is the operator and what is the operation and what is the result here. So 10 equals to 20 is equals to false, natural, because they are not equals to each other. Okay, so let us come back here and say n1 is not equals to n2. Of course, yes, this is going to give me the value as a true, because 10 is not equals to 20, as simple as that. You may say 10 is greater than 20. If it is the case, let's see whether it gives us a value true or false. Now, naturally, if you are looking at the greater than, you can also look at the less than. So probably one will be the opposite of another. 10 is greater than 20. No, that's true. And no, that's true in the sense 10 is not equals to or 10 is not equals to. So not equals to, sorry, my bad. It's 10 is greater than 20. Of course, it is not the case, and that's the reason why you are getting false. And 10 is less than 20, which is the case. And that's the reason why you are getting true. As simple as that. Let me copy this again, and I'll say this is the next one. That's greater than equals to, less than equals to. Let's verify that result as well. And if I say run, you will see that no, this is not greater than or equals to 20, and this is not less than or equals to 20. That is true. So precisely, this is nothing new to you. You might have already seen these examples earlier in other languages as well. If you have used the C language, then exactly similar to that. There's no change here. Okay. So this is the way we can do it. Okay. Today we are now going to talk about how to get the value from console. Tomorrow we'll talk about it. Actually, Sagar, you answered your own question. How to give the input from the console. The answer is the input itself. What do you mean by that? I'll talk about it tomorrow. Okay. So we'll get the input from user tomorrow, and we'll perform maybe more than these operations, and then we'll see how it goes. Okay. Okay. So probably we have just looked at the data type, and we have looked at something like the comparison and the mathematical operators. Now logical and other operators we will see in tomorrow. because for that we have to write some conditional code or something like a statement, the conditional statements. So we'll see this tomorrow. Tomorrow, we are going to start with the next topic, which is going to be the crucial topic, not only for Python, for all the languages. And I'm talking about something called as the function. Function is the basic building block of reusing your code. And that's the reason it's going to be very important. So almost every single day, we are going to write the function. So tomorrow, we'll see some basic functions. And tomorrow, we'll also see how to get the input from user and how to deal with the function, deal with the advanced functions. Okay. So tomorrow's topic is going to be a little bit crucial because every single day we are going to deal with the functions. Anyways, I think we have covered maybe a little bit than yesterday. We have started writing the code. Not today, but at least from tomorrow, you'll be able to get that utility working, and probably starting from tomorrow, you'll be able to copy and paste the code. Okay. So today, I think the code was not that extensive, hardly maybe 10-15 lines of code. But starting from tomorrow, because we are going to deal with many different concepts, so you have to write some extensive code. In that case, if you are not matching with the speed, then probably you can copy and paste it. So starting from tomorrow, you will get that utility working for you. Yes. Yes, there will be an assignment, not for today. Starting from tomorrow, you are going to get an assignment either on the same day or on the alternate days. Okay, Sagar, today we are not having that much of things covered. So probably starting from tomorrow, you will be getting some assignments. Okay, so I think it's better we can call it a day. I think I already have shared the PDF file with you. I'll again share the PDF file because I've just modified a couple of things. I'll also share this code in your Git repository, and from there you can get the code. You can also get the code on the WhatsApp group as well. Yes, I'm going to share these things on the WhatsApp as well as on the Git repository as well. Okay, no problem. Thank you very much, guys, for attending today's session. I'll see you tomorrow exactly at 8 o'clock, and have a great day. We'll see you tomorrow. Bye-bye.